Greetings math lovers and welcome to yet another video from our channel. As always, we try to find beautiful problems to propose to you in order to discuss together the solutions for these problems. This time we have found, let's say we are proposing to you a problem from the Russian Math Olympiad of 1990. It is a beautiful inequality for which we will present two solutions. We will present a straightforward and let's say technical easy solution and another interpretation, geometrical interpretation and solution to this inequality. So, without further ado, let's read the request of the problem. Prove that for all positive real numbers x, y, and z, such that x, y, and z are greater than 0 but smaller than 1, we have that x times 1 minus y plus y times 1 minus z plus z times 1 minus x is smaller than 1. If you want to present a solution to this problem, please pause this video and go to the comments to present what you think is a proper solution to this problem. Please bear in mind that all the solutions that our channel present are in the spirit of what the name of this channel represents. So we are trying to give very elegant, short solutions, but that do not need any special mathematical knowledge. So let's call them possible straightforward solutions. So let's go to the solution of this problem. As I said, we will have two solutions. We will present two solutions. One straightforward with known techniques in inequalities and another geometrical solution. I have covered the solution in order for us to go through it step by step together. Let's see the first solution of this problem. As we said, the first solution will be a formal one and the other one will be a geometrical interpretation of the given inequality. So we start by the straightforward solution. We, first of all, will expand everything that is given to us on the left-hand side of the problem. So x times 1 minus y plus y times y minus z plus z times 1 minus x. We expand everything and we have x plus y plus z minus xy minus yz minus zx. So this we will call the first expression, we will call it asterisk or expression number 1. Now, we have that this given expression over here is smaller than x plus y plus z minus xy minus yz minus zx plus xyz, because given that these three numbers are positive numbers, their product, their multiplication will also be a positive number. So these two sides, the left hand side and the right hand side, differ only from this factor xyz, and given that the right hand side we have added something positive, it is a true expression, and we will call this expression number 2. But now we can transform this expression over here, and we can say that this expression is equal to 1 minus x times 1 minus y times 1 minus z, and this expression over here is smaller than 1 because we are deducting from 1 something which is positive, because x, y, and z are all of them are positive numbers, so this product over here will be positive. So from 1 we take away something positive and this expression will be smaller than 1. This expression, we call it the expression number 3, and we will have that this expression over here is smaller than 1, but this expression over here, which is equal to the expression up here, is smaller than 1. So from combining expressions 1, 2, and 3, we will get the desired result that x times 1 minus y plus y times 1 minus z plus z times 1 minus x is smaller than 1, because as we said, this equal to this, but this is smaller than this expression over here, and this expression over here itself is smaller than 1, which gives that this expression is smaller than this, which is smaller than 1, and the desired result. Now we will go to the geometrical interpretation and solution to this problem. To do so, we will take into consideration an equilateral triangle ABC with the figure that we have done over here, with side length equal to 1. So this means that AB is equal to BC is equal to CA is equal to 1. Now, we will take points M, N, and P respectively on the sides AB, BC, and CA such that AM is equal to X, and given that AB is equal to 1, means that BM will be equal to 1 minus X. We will take BN equal to Z, so CM will be 1 minus Z, and we will take CP equal to Epsilon, and AP will be equal to 1 minus Epsilon. So we will get over here BM1 is equal to 1 minus X, CN is equal to 1 minus Z, and AP is equal to 1 minus Epsilon. Now, for the formulas of the area of a triangle, we will get that for triangle AMP, triangle BMN, and triangle CNP, we will get the following formulas. We know that for a triangle, for the area of triangle AMP, we will have two sides, half of two sides, multiplication of two sides multiplied by the sinus of this angle over here MAP, which is equal to 60 degrees, because we said that triangle ABC is equilateral. We will have that area of AMP will be equal to half of AM times AP times sinus of MAP. We do the substitutions that we will have that AM is equal to X, AP is equal to 1 minus Epsilon, and the sinus of 60 degrees is equal to square root of 3 divided by 2. So similarly, we will get that areas of triangle BMN is equal to 1 divided by 2 of Z times 1 minus 6 times square root of 3 divided by 2. And the area of triangle CNP is equal to 1 divided by 2 times epsilon times 1 minus Z times square root of 3 divided by 2. And we will also consider the area of the big triangle, the equilateral triangle ABC, which is equal to 1/2 of 1 times 1 times the sinus of 60 degree, which is square root of 3 divided by 2, and the area of triangle ABC will be equal to square root of 3 divided by 4. Now we see that in this triangle over here, the area of triangle AMP plus area of triangle BMN plus area of triangle CMP is smaller than the area of the big triangle ABC, because there is a difference between them of the area of the triangle M and P. So we do this inequality. Area triangle AMP plus area triangle BMN plus area triangle CMP is smaller than the area of triangle ABC. We make the substitutions of all the expressions that we got up here, and we will have that square root of 3 divided by 4 x times 1 minus epsilon. We substitute the areas of all three triangles, which is smaller than square root of 3 divided by 4, and we can divide both sides of this true inequality by square root of 3 divided by 4, and at the end, while we take away the square root of 3 divided by 4 for all the factors, we will get the desired result, what we wanted to prove, that x times 1 minus epsilon plus epsilon times 1 minus z plus z times 1 minus x is smaller than 1 in a geometrical interpretation. So, if you liked this solution, as always, please help our channel grow by liking the video, making a comment if you have some observations or some other solutions to this problem, and please don't forget to subscribe. Until our next video, goodbye.